Hello friends, welcome back to the class of thermodynamics. Till now we have seen about second law of thermodynamics, the refrigerator, heat pump, Kelvin Planck statement, process step. In today's session we will see some problems based on the second law of thermodynamics. Now, first problem. See it carefully. What does the first problem says? Using an engine of 30% thermal efficiency to drive a refrigerator having COP of 5. What is the heat input into the engine for each megajoule removed from cold body by a refrigerator? So we are using an engine to drive a refrigerator. The efficiency is 30%. Now COP of refrigerator is given 5. We have to calculate heat input to the engine for each megajoule removed from the cold body by the refrigerator. Okay, so there is engine which is driving a refrigerator. The efficiency of engine is given 30% and COP of refrigerator is given 5. Also it is given you have to calculate the heat input into the engine for each megajoule removed from cold body by the refrigerator. Okay. Now how to proceed? First of all, you should write all the given data. Now given COP of refrigerator, how much? 5. Correct? Now for each megajoule removed from cold body, we have to calculate the work done. We have to calculate the work done. So formula is given COP of refrigerator equals to Q removed by W net. This is the formula. Now what is the value of COP of refrigerator? In question it is given COP is equals to 5. Okay. Next, what is Q removed? Here it is given each megajoule removed. So Q removed is 1 megajoule. And W net you have to find. So take W net this side on the left hand side, COP will come in the denominator. So W net will be Q removed divided by COP of refrigerator. Now Q removed is 1 megajoule, COP is 5. So W net will come 200 kilojoule. Correct? Now for 200 kilojoule of work output, the efficiency of engine is how much? 30%. For doing so much amount of work output, the engine is having efficiency of 30%. Now, what will be the heat supplied? What will be the heat supplied? So what is the formula for the efficiency? Efficiency is nothing but output by input. What is the output in terms of work? What is the input? Heat supplied, which you have to find. So write on the formula. Efficiency equals to work upon Q added. This Q added is nothing but supplied heat, which you have to calculate. So Q added will be, take this on the left hand side and this in the denominator, you will get Q added equals to W net by thermal efficiency. On W net we have just calculated 200 kilojoule efficiency. Here it is given 30%, so in fraction zero point 0.3. From here we will get the Q added or heat supplied. It is coming 666.67 kilojoule. So this is your first thing. What is the heat input to the engine? You have calculated the first thing. Now coming to second part. If this system is used as heat pump, same system is used as heat pump, how many megajoule of heat would be available for heating for each megajoule of heat input to the engine? Now you have to find the value of Q1. Here you have found the value of Q1 in case of engine and refrigerator. Now here it is engine and heat pump. In place of refrigerator there is heat pump. So again you have to find the Q1. How you will find? Now I have told you relationship between coefficient of performance of heat pump and coefficient of performance of refrigerator. Coefficient of performance in short is known as COP. So COP of heat pump is equal to COP of refrigerator plus 1. Now COP of refrigerator it is given in the question 5. So 5 plus 1 is 6. This is the COP of heat pump. Now heat input to the heat engine how much? Again it is given 1 megajoule. 1 megajoule of heat is available. Okay. Now work output. What will the work output? How you will get the work output? Now what is the formula of COP of heat pump? COP of heat pump is nothing but Q added by work. Q added by work. Or in terms of efficiency, it is represented as W net by Q added. Okay, so W net will be how much? Q1 times Q added times efficiency. What is the Q added? 1 megajoule. What is the efficiency? 30%. So work output will be 300 kilojoule. 300 kilojoule. Now I told you formula of COP of heat pump. Q added by work. Now Q added will be COP times work. Now COP of heat pump is how much? 6. Work is how much? Just now you have calculated 300. So you will find the Q added. That is 1.8. So in both the cases, you have to find the Q added. One in the case of refrigerator, another in the case of heat pump. Again I am explaining you. See what is the COP of refrigerator given? 5. Okay. Now you have to find for each megajoule removed. What is the work? So formula of COP of refrigerator is Q removed by work. Now work you have to calculate. Q removed is how much? 1 megajoule. COP is 5. From here you will get the work net, the 200 kilojoule. This is for the case of refrigerator. Now, for this much amount of work output, the efficiency of engine is 30%. Now, what is the formula of efficiency? W by Q added. W by Q added. So, Q added is, you have to find this. So, Q added will be W net by thermal efficiency. Now, W net is how much? Just now you have calculated 200 kilojoule and efficiency 30%. Put the values, you will get Q added. It is coming around 66.67 kilojoule. Now this is the first case when there is a refrigerator. In the second case, refrigerator is replaced by heat pump. So again for this case also you have to find the heat input. Now here how to find heat input? It is given this amount of heat is removed 1 megajoule and now what is work output in terms of efficiency? In terms of efficiency, that's the formula of efficiency. You can see here. Okay, so from here you will get W net in the case of heat pump. Next, COP of heat pump. Formula is Q1 by W means Q added by W. So Q added will be how much? See, this Q added is different, this Q added is different. This is heat added to heat engine. Now we have to find this Q added which is added to the in the case of heat pump. Okay, don't confuse here. Here heat is input to the heat engine. So you talk about efficiency. Here you have to find COP of heat pump. So you have to find this Q added. So this is equal to COP of heat pump into W. So COP of heat pump, just now from this relationship you got 6 and work is 300 kilojoule. Not 200. 200 was in the case of refrigerator. Now here in case of heat pump it is 300 kilojoule. From here you will get the value of Q1. Correct? So what happens? People confuse here. They put same thing here and same thing here. So don't confuse. For the heat engine, heat input is different. Whatever work it is producing, this work is utilized to run the heat pump. In case of heat pump, Q is different. You have to find this Q, which is used in case of heat pump. Correct? Practice these problems again and again. Then only you will be able to solve it. Now, second question. A household refrigerator is maintained at 2 degrees Celsius temperature. Every time a door is opened, warm material is placed inside, introducing average of 420 kilojoule, but making only a small change in the temperature of refrigerator. What is happening? The temperature of refrigerator is maintained 2 degrees Celsius. It is opened many times. Okay? And whenever it is opened, the average heat is 420 kilojoule. When you open the door, you put some warm material inside it. So average heat is 420. Now, door is open 20 times a day, means you are opening the refrigerator door 20 times in a day. And refrigerator operates 15% to the ideal COP. Whatever is the ideal COP, the refrigerator is operating at 15% of the ideal COP. Cost of work is given in terms of rupees 0.32 rupees per kilowatt hour. Means for each kilowatt hour, 0.32 rupees is cost. You have to find the monthly bill of the refrigerator. Like this, you can find how much monthly bill comes due to use of refrigerator. Your electricity bill comes na, so how much electricity bill is coming from by using the refrigerator. The temperature of atmosphere, surrounding temperature is given 30 degrees Celsius. Now you have to start solving. Okay. Now draw the diagram for the case of refrigerator. Now what it is said, refrigerator is maintained at 2 degrees Celsius. This is the lowest possible temperature. How much? 2 degrees. So in terms of Kelvin, 273 plus 2, 275 Kelvin. This is the lowest temperature. Next, highest temperature, atmosphere temperature, surrounding temperature is given 30 degrees Celsius. So in terms of Kelvin plus 273, it will be 303 Kelvin. So both the temperatures are given to you. Correct? Now, ideal COP of refrigerator. What is the COP of refrigerator? T2 upon T1 minus T2. Put the values, you will get ideal COP. Now, refrigerator is operating at 15% of the ideal COP. So 15% of this ideal COP will be how much? This much. After calculation, you will get this much. So this much is the actual COP. Correct? Now, heat to be removed in a day. In a day, it is said it is removing average 420 kilojoule. And door is open 20 times. So 20 into 420, 20 into 420, 8400. So this is the amount of heat removed in a day. In a day, you are removing this much amount of heat. You got COP, you got heat. So you will get the work. What is the relationship? COP equals to Q divided by work. So work is nothing. We will get the work. Work will be nothing but Q2 by actual COP. So you will get this much kilojoule per day. This much kilojoule per day. Now per hour, we have to find kilowatt hour. How you will find? What is the relationship? Just now see. I am going to describe here in the red color. Okay? See. What is joule and watt? Watt is equals to how much? Joule per second. Okay. Now you want watt hour. Watt into hour. Watt into hour. Correct? So joule per second into hour. This H represents hour. Okay. Now here there is second, so you have to find get here second. Here it is in second, so here also you want second, or reverse you can say. Here is hour, you want here hour. How it will come? In 1 hour there are 3600 seconds. In 1 hour there are 3600 seconds. So divide this kilojoule per day by 3600. Divide this thing by 3600. And you will divide this by 3600. You will get this in terms of kilowatt hour. So this is the work required. Now, why we have calculated kilowatt hour? Why we have calculated kilowatt hour? Why? Because this cost of work is given for per kilowatt hour. For per kilowatt hour, the cost is 0.32 rupees or 32 paisa. Okay? So you have to calculate in work in kilowatt hour. For converting into hour, divide this by 3600. Now, this is the work required. So, what will the bill? How much will the bill? This much into the cost 0.32. This much into 0.32. But this is for 1 day. This is for 1 day. You have to find monthly bill. In a month, how many days are there? Average you will take. Sometimes 28, sometimes 30, sometimes 31. So average is 30. We will take average 30. So this much work required into this much amount money, and this is per day. So to find month. In a month there are 30 days. Multiply all these things, you will get this much rupees. This is the monthly electric bill due to the refrigerator. Correct? So these are the two types of problems which can come in any exam. In your engineering exam, in your competitive exam, anywhere it can come. So I told you the two kinds of numericals. So this will help you or guide you in some manner. The problem can come in this kind. Okay? I hope it is clear. So it is over for today. We will meet you in the next section of thermodynamics. Till then, goodbye. Take care.